Hi everyone, I'm Peiling, a PhD student at the Creativity Lab at UC San Diego. Today I'm going to share a ready-to-use log interface that helps you better understand log messages to facilitate the inspection and debugging of your programs. This work was done through collaboration with my fellow student Fuling and my advisor Haijun. Logging and printing are the dominant techniques for inspecting and understanding programs. However, the form of the output has not changed since they were originally introduced decades ago, as a linear string of text that resides in a terminal, console, or log file. Therefore, it is difficult for programmers to locate, synthesize, and understand logs ad hoc when they program. When a programmer wants to log the attributes of data points in a scatter plot, for example, mapping the linear string of logs to the visual elements of the visualization is quite hard. In addition, programmers often need to switch between the code editors, the log console, and web pages to understand the output in context. From time to time, the programmer may just stare at the streams of the numbers and ask themselves, what does this log mean? Or where does this log come from? Our formative study with 7 experienced programmers investigates the current challenges in reading those logs that occur during the programming process. And we summarize the following 4 points. First, as we mentioned above, the log output lacks meaningful organizations. As a result, programmers often need to manually structure and organize the linear streams with symbols and spaces. And second, interactions and explorations of complex, nested, and recurring objects are often tedious and time-consuming, as those log data structures lack informative visualizations and interactions. And as the programmer switch between different views and windows, those log messages with minimal contextual information about where they come from and what they are relevant about become really hard to track and understand. And finally, programmers love logging as it's a low-effort method. There's no extra setup, it's pretty easy to turn on and off, and it's so flexible that you can put it almost everywhere in the code. So any new log interface should not sacrifice the versatility and simplicity while supporting the challenges above. We present Logit, a new log interface that augments the traditional logging mechanism with interactivity, context, structure, and visual representations. Let's take a look at Logit in the context of web development. With Logit, a JavaScript programmer adds log statements in the code, just like their familiar console log statements, and the output is rendered on the front end directly, side by side with the existing page elements, instead of a separate console panel. A typical use case of log statements is to print and inspect program variables, especially complex data structures. When inspecting these complex objects, the programmer may want to inspect how their properties change over time. In this example, the programmer wants to see how the viewing distance changes. Today, they need to open the log messages one by one like this, or rewrite the log statements in the source code to change their output. With Logit, however, their interaction with one log message is synchronized to all other logs originating from the same log statement, and double-clicking on the property name highlights the property, which is also synchronized to all the log outputs. This synchronization is possible because Logit structures all the outputs from the same statement as log streams, which serves as the foundation for rich interaction, visuals, and context. Using the traditional textual logging mechanism to debug visual interfaces can be challenging. Here, the programmer is trying to figure out why the customized button click doesn't work. To debug, they print out the bounding box of the button and the events to see if the click falls into the button. And you can see these numbers are just not helpful at all. With Logit, however, the programmer can visualize the bounding box as a rectangle and the location of clicks as dots on the page, allowing the programmers to easily pinpoint the problem. Here it looks like the bounding box of the button didn't account for the offset of the canvas. So once we add it to the formula, the code works fine as expected. Finally, streams augment logs with rich context. Programmers often need to situate log outputs with source code and visual elements to understand the logs and program behavior. However, frequently switching between these fields often leads to losing context. For example, it is often challenging to recall the function that these log outputs come from. Logit, on the other hand, indents logs based on their statement scope in the source code, enabling the programmer to recognize rather than recall the context of the source code. Here, it is easy to tell which outputs come from inside or outside of the for loop. Logs can also be further divided into different columns based on the top-level declarations they belong to. This allows further division of the logs from different functions or different sources like files and packages. Beyond code context, logs can be attached to elements or through a chaining function so that they can be viewed in the context of the page elements. Here, the programmer attaches this log stream to the button as it logs the click events which are related to that particular element. To mitigate visual clutter, the programmer can also use an area filter to only inspect logs that are attached to the elements within the filtered area. The structures, interactions, visual representations, and contextual information that logit supports enable new ways of using and understanding logs for programming tasks. We demonstrated logit in a web development environment, but many of the proposed techniques can be broadly applied to a variety of programming languages and platforms. Logit is available today as an NPM package. You can easily install it for your existing project and enjoy this new way of understanding logs and inspecting programs. This whole system is also fully open source. Please check it out on the Creativity Lab website or my personal website. You can also find the full paper, the videos, and other resources for the project. Thanks for listening, and I hope you enjoyed this talk. Please feel free to contact me with any thoughts or questions. Thank you.